Okay, in this video we are looking at how we carry out a titration, what equipment is required for a titration, how we actually go about using that equipment, why that equipment is used, how we go about doing the calculations, and calculate the volume of a chemical that we're going to add in our titration, or calculate a concentration that we're going to add in our titration. Okay, so the first thing we look at is how we actually do it, what the step-by-step process actually looks like. Okay, so we have different pieces of equipment which are going to be required. So we have a burette, that's used to measure the acid, and we would be able to predict how much acid we're going to add into our alkali to neutralize the alkali. Okay, so we would have our alkali in the conical flask. So this is our conical flask. Okay, so we would have measured out a particular volume of alkali using a pipette. So this is our pipette. And we would obviously add indicators to that. So depending on the indicator that we use, we'd get a colour. Okay, to indicate that it had a pH of above 7. And then we'd add enough acid to actually get the indicator to change colour, to indicate that it had gone from an alkali to a neutral solution. Okay, so a few steps to do this. If the samples are solid, we need to look at dissolving that sample and in a known volume, which is usually a litre. Calculating the number of moles of that solid sample. There was a video that showed us how to do that on the YouTube channel, but remember we'd use the equation of number of moles equals mass over molecular mass. Okay, and then we'd combine that with N equals CV equation. So, and then rearrange that to get your concentration to work out, so you know what your concentration of your acid is, of your alkali is, rather, sorry. Okay, then you're pipetting a known actual volume, for example 25 centimeters cubed. Okay, so you know how many moles of your alkali you've got, because you've got a value for your concentration and you've got a value for your volume. So you can rearrange your equation to work out what your number of moles for your base is. So I'm going to call that number of moles B. Okay, you've got your acid in the burette. Okay, and you run it through the burette until you get a colour change. So then you know what your volume is. Okay. You can look at the equation to work out what the number of moles is. So you can rearrange that equation again to get your concentration. So the solution from the burette is added until the base is added a drop at the time with swirling until the end point is approached. That's the point at which the neutralization happens. Okay, and you get eventually I get a colour change to see that it is completely reacted. And then you record off on your burette the volume of acid that you've actually added into the conical flask, and then from that you can look at working out your unknown values, either the concentration or the number of moles. Okay, so we can look at how we actually would go about carrying out an example calculation. So I've got an example here where I've added some sodium hydroxide, and I need to know what concentration of sodium hydroxide is required to neutralise 32.5 centimeters cubed of 0.5 molar sulfuric acid when I'm only using 25 centimeters cubed of sodium hydroxide solution. Okay, so my first thing is I know I've got my concentration of sulfuric acid. I've also got my volume of sulfuric acid, so I can calculate the number of moles of sulfuric acid that I'm actually using. Okay, and then I get a value of 0.01 moles in this example. Okay, the important thing to remember is I need to divide my volume by 1,000 to convert my volume into litres. So I had a volume of 32.5 centimeters cubed. Okay, and therefore I need to divide that by 1,000 to get my volume in litres. Okay, so that 20 is a mistake. Sorry, that should be 32.5. Okay, that I'm dividing by 1,000. Okay, then once I've looked at my volume, I need to look at balancing the equation. Okay, so for every 1 mole of sulfuric acid, I'm going to end up with 2 moles of sodium hydroxide. So I need to multiply whatever number of moles of sulfuric acid I got. I need to multiply it by 2 to work out the number of moles of sodium hydroxide. Okay, so if I had 0.01 moles of sulfuric acid, I would end up with 0.02 moles of sodium hydroxide. Okay, and then I need to rearrange my equation to calculate the concentration. Okay, I know what my number of moles is. I've calculated that from my ratio. It tells me what the volume is in the question. So I can do concentration equals number of moles divided by volume to work out what my final concentration is. Remember that my value is going to be in moles per decimeter cubed. So again, I need to convert my volume into litres by dividing by 1,000. Okay, so we can look at different examples and be able to predict how to calculate the concentration of a base if we know how much volume we've added. Okay, we can also work out how to calculate the number of moles by looking at the ratio of the balanced symbol equation.